Fine, we'll leave it on that. Oh yeah, now it's working. That was weird. Yeah, I do want to change those. I didn't change anything. That's so strange. All right. How's everyone doing? Let's do this one last thing. I want to set up the chat to be on here. All right, everything should be working good now. Yeah, should be going good. Okay. Well, what does that mean we're going to do? There's nobody in MathLab, which does seem to be the norm as of late, unfortunately. We did Algebra 2 last time, right? Should we do some calc? Yo, thanks for those likes. Sweet. Um, yeah, let's do some calc. We did Algebra 2 last time. What is MathLab? I'm usually in the chess lives. Yeah, so this is mainly a math channel, if you couldn't tell by the name. But we just do chess too. So MathLab is just like you come and you bring your math questions basically. It takes place in a Zoom, but here's good too. I mean, here's kind of better, honestly, for a few different reasons. But yeah, so we're here to do math. If you got any math questions, you can pop them in the chat. But yeah, we'll do chess later, of course, but just not right now. Alright, so basically what we're going to do, until somebody has a math question, is we're going to do these problems. Because this is kind of a series that I'm trying to do on YouTube. Trying to keep up with on YouTube. Where I'm going through all of the problems, all the examples in these two textbooks, this Calc and this Algebra 2 textbook. So, yeah, that's what we're doing. So I've got a lot of them listed out here. So we're just going to kind of run through them one by one and record some videos about them. And then those will go on YouTube at some point, is the idea. And again, until somebody has a math question, if anyone's got a math question, you can just pop that in the chat real quick and we can get to that. But until then, this is what we're going to do. Let's put that over here. Actually, I should make that big. Okay. Yeah, so this is what we're doing. So let's do this problem. They want us to find the slope of the graph x to the fourth at these various x values. So we'll have nice shortcuts to this. Oh, no, we do have a nice shortcut to this now, don't we? We found the power rule. we've proved this power rule right here, at least for integers. So now it's real nice. We can just do that. We don't have to worry about the limit definition. So what is the derivative of x to the fourth? Well, we just use the power rule. We take the 4 to the front, and we decrease the power by 1. And then, now that we have the function, we just got to plug them in. So now we'll just be like, well, what is f prime of negative 1? Well, that is 4 times negative 1 cubed. So negative 1 cubed is negative 1 times 4 is negative 4. So the slope there is negative 4. And then what about at 0? Well, what is f prime of 0? Well, 0 cubed is just 0, and then 4 times 0 is just 0, so that's just going to be 0. And then f prime of 1, well, it's just like negative 1, except for positive 1 cubed is still positive 1, so that'll be positive 4. And that totally makes sense, because if you think about what the graph looks like, the x to the fourth graph looks something like this. So you got like this point here, got your slope of positive 4. This point here, got your slope of negative 4. And then right here at 0, you got your slope of 0. So all of that makes sense based on the graph. You have any content geared more towards children? My daughter is 7, so we're not quite ready for pre-calc. What do you mean you're not ready for pre-calc? She's 7. It sounds like she's 5 or something like that. If you're 7, you're ready for pre-calc. I do appreciate you educating the youth for free, boss. I'm trying. Think a lot more education should be on YouTube and more like for the masses rather than individually. Thought this was a midday chess stream? Sometimes. Although, this is always when we do MathLab. This is MathLab time. It has been for 3 years now. This is the 3rd year. Okay. Good stuff. On to the next. Find an equation of the tangent line to the graph f of x equals x squared when x equals negative 2. All right, cool. All right, so here we got to write the equation of a tangent line. That's what's something you do all the time in calculus. And that's why I harp on it so much in Algebra 2. What 2 things do you need to write the equation of a line? You only need 2 things. You need a point and you need a slope. You need a point and you need a slope. Because once we have the point and the slope, we'll use point-slope form. What is point-slope form? Well, we should know it. M times x minus x1 equals y minus y1. And of course, you could use y equals mx plus b and then do the whole solve for b thing. But I think this is no good. Or I think that's no good, because I think this is just easier. You just get the point and you get the slope and you just straight plug it in. And if you're confused or having trouble memorizing this formula, recognize that it's basically the exact same thing as the slope formula, like y2 minus y1 over x2 minus x1. They just like cross multiplied. They multiplied that over to the other side. So that's how you remember that. It's not that difficult to remember because it just comes from the slope formula. But then, so what do? Let's find it. Well, first off, let's find the point. So they tell us that it's going to be at x equals negative 2. And well, if it's x equals negative 2, we just need to find the y value. So we need to use this equation to find the point. We need to do f of negative 2. And that's going to be negative 2 squared, so positive 4. So that's our point. Negative 2, comma, positive 4. So then we just need the slope. The slope is from the derivative. That's the only way we can get the perfect exact slope there of the tangent line. That's the definition of the derivative. So let's use the power rule. Let's find the derivative. So f prime of x. So we're going to move the power to the front. So move the 2 to the front and decrease the power by 1. So x to the first. And what's x to the first? X to the first is just x. So 2x. And then now we need to find the slope there. So it's at x equals negative 2. So let's find f prime of negative 2. So see how we found f of negative 2? And that got us the point. But now we're finding f prime of negative 2. And that'll give us the slope. So 2 times negative 2, that's just 4, negative 4. And so that's our slope, negative 4. So now that we have the slope and we have the point, we just need to plug that into point-slope form. So negative 4x minus negative 2, so plus 2, equals y minus 4. And there we go. That's the equation of the line. That's really that's our answer. We don't need to do anything more from there. Now, a lot of teachers might ask you to put it in like y equals mx plus b form and slope-intercept form. And so to do that, we just got to multiply everything out and start for y and solve for y. So we distribute the negative 4, negative 4x minus 8 equals y minus 4. And then we just got to add the 4 over to get the y by itself. So negative 4x minus 4 equals y. And that is that form of the line. So both of those for this question should be the acceptable answer. All right, good stuff. Good stuff. Ooh, here we got a bunch of power rule practice. Bunch of power rule practice. All right, so we got to find the derivatives of all of these, and it may not look like it, but all of these are power rule problems. So first off, recognize to use the power rule, it's got to be x to some power. So we have to rewrite all of these as x to some power. So this is, again, where our algebra 2 rules start coming into play. Because how do we do 2 over x? How do you rewrite that? Well, if you're dividing by x, that's a negative exponent. So this is 2 times x to the negative 1 if we rewrite that function. And something that's really important to keep track of here is we haven't taken the derivative yet, right? Sometimes we have to do a lot of work before we even take the derivative. So this is just rewriting the function. Now we can take the derivative. So we'll note that by saying y prime, this prime is like the derivative, it equals what? So how do we do this? Well, it's the same exact thing. We move the power to the front. So we'll say negative 1 times 2. Because, of course, those coefficients always stay there when you're taking derivatives. And then the power decreases by 1. So be careful. Make sure you're doing that the right way. Because it's like currently negative 1. And we're going to subtract 1 from that. So what are we actually getting when we decrease the power? We're getting x to the negative 2. As negative 1 goes down by 1, negative 2. And then how do you rewrite this? Well, I mean, we're done, right? Negative 2 times x to the negative 2. Like, that's the derivative. But often it's nicer and people like you to write it so it kind of looks like how it did in the beginning. So, in other words, just get rid of the negative exponents. So it'd be kind of nicer to rewrite it as like negative 2 over x squared. And just notice, I mean, this is really important, that like this negative 2 exponent only goes to the x. It doesn't go to the negative 2 as well, so it stays in the top, right? Like we don't have this. We don't have the negative 2 going to everything. It's just going to the x. So the x goes to the bottom, but the negative 2 stays at the top. All right, so that felt like a whole problem, but that was just part A. So what do we do the next one? Well, the next one we don't even have to rewrite. See, it's already as just like the variable to some power, so we can just go ahead and do it. So when we find f prime of t, what are we going to do? Well, we're going to bring the power to the front. So I'll go ahead and write it out now. We're going to do the 2 times the 4 and decrease the power by 1. So 2 decreased by 1 becomes 1. And then it's still over 5. Because remember, basically, this 4/5, that coefficient, that just stays there. It just remains untouched. We just bring the 2 to the front, decrease the power by 1. So now we'll just simplify a little bit. Like 2 times 4, that's 8. T to the first, that's just t. So 8t over 5. There's our derivative. If you want to rewrite it too, there's no better way. But it is very important to know that we could bring that t to the outside if we wanted and make that like 8/5 t. People get really confused about that. But both of those are totally valid ways to write that. All right, what is next? So we need to rewrite this as some power as well. So we'll leave the 2 there. And then square root of x. How do you write the square root of x as x to some power? Well, we should know this. The square root is the 1/2 power. So that's x to the 1/2. Again, algebra 2 skills coming into handy. And then what do you, now we take the derivative. We haven't even taken the derivative yet, but now we can take the derivative. So y prime is, well, it's the exact same thing. We're going to bring the power to the front. So we'll do 2 times 1/2 and then decrease the power by 1. So x, I'll write it out for now, to the 1/2 minus 1. And beautiful, that's our derivative. Let's make it look a little prettier. So 2 times 1/2, that's awesome. Those just cancel out. And then what's 1/2 minus 1? Well, we can find a common denominator, but we should know that 1/2 minus 1 is negative 1/2. So we got x to the negative 1/2. We can do a little better with that. It's a negative exponent, which means we got to put it in the denominator. We got to divide by it. And it's to the 1/2. So just like we did in the beginning, let's put that back as a square root. So square root of x. And that's our derivative. Beautiful. And see how it's nice that like we put it back in a square root. Like our original answer didn't have any like fraction exponents, didn't have any negative exponents. So our answer really shouldn't either. All right, last hard one. So we got to rewrite this as x to some power. Well, so first off, we got our coefficient here, and like all the numbers, that's just going to sit. That's just going to chill. So we'll just have the 1/2. And then we got to rewrite this as some power. So it's got everything here. So first off, it's in the denominator, which means it's going to be a negative power when we bring it to the top. And then it's a cube root. So that means it's 1/3, because that's how you write a cube root, just like square root is 1/2. But then it's x squared. So it's actually to the 2/3. So this is what we have, 1/2 x to the negative 2/3. And so now that we've done that, now we're ready to take the derivative. So we'll say that the derivative is, let's see, let's change colors, because this is getting a little cluttered here. So we'll say that y prime is, well, we'll bring the negative 2/3 to the front. So negative 2/3. But that's still multiplied by the 1/2. And then x to the negative 2/3 minus 1. So think about that, negative 5/3. And then now we just got to simplify. So how is this going to simplify? Well, first off, the 2's are going to cancel. And then look at what we got going on with the x's. So just for now, negative 1/3. And then we'll go ahead and deal with this, as it's a negative. So let's go ahead and move it to the bottom. So x to the 5/3. But then what is x to the 5/3? Because isn't x to the 5/3 like we have x times x to the 2/3? Because that's like x to the first. And if you're multiplying those exponents, or you're multiplying those bases, you would add the exponents. And 1 plus 2/3 is 5/3. So that's going to be the nice way to write that, because then we can get rid of the fractional exponent and rewrite that as negative 1/3 x times the cube root of x squared. And then that would be a good final answer, fully simplified final answer. And just to point out, if we would have kind of done that from here, so if we would have written this as negative 1/3 times the cube root of x to the 5th, well, then see what you can do there. This x to the 5th, that's x times x times x times x times x. So this group of 3 x's here, you could pull that out to the front. And so just the same, you would get the 3x, and then these 2 x's are left inside. So it's still the cube root of x squared. So see how either way you get that, it still works out. But I think seeing it like this is like cleaner in my mind, to like separate that up into its parts first instead of trying to simplify this cube root. But either way, that's some good stuff. that just follows with the gist of these. Like, all of these you can use the power rule for. You can even use the power rule for more complicated ones, which will probably be what we do next. You just have to rewrite it first, and then it's just fine. All right, and then this last one's the easiest one, actually. Surprised I save it for last. Because what is this here? This is just the power rule still, right? Because this is x to the first. And it seems a little weirder, but it works exactly the same way. So when we try to do the derivative, we're going to bring the power to the front. The power is just 1, so we're going to bring the 1 to the front. That's still being multiplied by the negative 3/2. And then we decrease the power by 1. So x to the 1 minus 1. Okay, well now we simplify, so we get negative 3/2, because 1 times negative 3/2 is still negative 3/2. And then x to the 1 minus 1, so x to the 0. And what is x to the 0? But 1. So this is just negative 3/2 times 1, or just negative 3/2. The x just went away. And that actually makes sense when you realize that this is in mx plus b form. So the slope, which is what the derivative is, the slope, is just right there, negative 3/2. And you see that when we use the power rule, we just ended up getting that same thing. So it confirms that idea. All right, good stuff. I am a math teacher. I apologize that y'all aren't into the math, but if you check out the name of this channel, it is MathLab, Jordan. So MathLab is the primary reason for this, and math is the primary reason for this. We do chess, of course, too. All right, more power rule stuff. Okay, so we're going to do the exact same idea. We're just going to have to rewrite these, and then we'll be able to use the power rule. All right, so we're doing more power rule stuff, because if you see, all of these are really just power rule problems. We just got to get a lot of practice with it. So we got to rewrite it, of course. So this is, let's see, the 5/2 just stays. And then x to the negative 3, because of course negative exponents, fractions. And then that means, so when we take the derivative of it now, because again, very important to remember that rewriting is not taking the derivative. That is just rewriting the actual function. Now we're going to take the derivative of it, and it's going to be the 5/2 just stays. But then we bring the power and multiply it to the front, so multiplied by negative 3, and decrease the power by 1. So negative 3 minus 1, negative 4. And then from there, that's it. That's the derivative. You just got to clean it up. So how's it going to look when we clean it up? Well, we got the 5 times the 3, so that's negative 15 over 2. And then x to the negative 4, which means we got to bring it to the denominator. So put the x to the 4th in the bottom. And that's the best we got. Okay, now b, you see b is basically the same, but this cubed is going to all of it. So we definitely need to just distribute that first. I've got to realize, like, yeah, if we're going to follow the power rule, it's got to follow the exact power rule. It's just got to be x to some power, not 2x to some power. Then we got to use different rules. So we just got to make it x to some power. So we distribute that power. So 2 to the 3rd is 8 times x cubed. And then honestly, we're not even going to do this whole problem, because notice how this is the exact same thing, except for it's an 8 instead of a 2. So if you look at our final answer, it's going to be the exact same thing, except an 8 instead of a 2. So negative 15 over 8 times x to the 4th. And of course, you'd simplify if you could, but 15 and 8, that doesn't simplify, because 15 is just 3 and 5, and 8 is just 2. And so there you go. There's your answer. All right, now C. C is weird, because you wouldn't really write a function like that necessarily, right? But we can still rewrite it. So it's still x in the denominator, and we don't like that for power rule. You can't have that for power rule. So we'll bring the x to the top. So 7/3 times x squared. And I mean, from there, it's just classic power rule. We're just going to bring the power to the front. So 7 times 2, 14 over 3. And then decrease the power by 1. So 14 over 3, x to the first, which is just x. And then D, kind of see how D is same like with A and B. But let's do it all out just to make sure here. Because notice with this negative 2 onto the 3, that's going to kind of do some stuff. So here, it's not just the x that's going to the top, but it's also the 3 that's going to the top. So when we rewrite this, it's going to be 7 times 3 squared times x squared. So you should know your multiplication tables. 3 squared is 9. 7 times 9 is 63. So this function already is 63x squared. And so when we take the derivative of it, we're going to move the 2 to the front. 2 times 63, you should be able to do that easily. 126. 126 x to the first, which is just x. So there you go. Just see how all of these are just power rules. Sometimes you just got to rewrite it first. And there's still even more complicated ones that we could do, which I bet we'll get to next time. Oh, wow. There's a lot more complicated ones, actually. But yeah, we will get to those next time. Yeah, low D high minus high D low over low squared. I never liked that rhyme. I've actually always really hated that rhyme because it's not a rhyme. Like, low D high minus high D low sounds just as good as high D low minus low D high. Doesn't it? In my mind, it definitely does. Like, I can't even, like, promise you that's right. Low D high. Yeah, because I just remember top first. You just take the derivative of the top first. That rhyme, I never liked that rhyme. But also, that kind of, just in general, I'm not a big fan of, like, just tricks to memorize things. Like, just rhymes that make you memorize things. Because memorizing is not learning. Especially when other people don't know what you're talking about. Like, if some random rhyme your teacher uses, you might think that that's, like, classic and, like, standard that everybody uses. But then you go out and talk to other people, and you're like, they have no idea what you're talking about because it's just some random thing your teacher made up. Now, low D high minus high D low, I get that, like, everyone knows that. That is common. But my teacher didn't use that. I only just heard that from, like, calc lore. Like, from just online and stuff. My teacher didn't teach that. Okay, anyway, more power rule. Alright, so some more power rules. So this is just kind of to point out that if you got a bunch of functions added together, you just take the derivative of each one of them separately, which honestly we already knew, but let's just see how it works here and see how easy it makes these compared to using the limit definition. So all we're going to do is we're going to bring the power to the front. So x cubed, we're going to do the x cubed first. So bring the power to the front, bring the 3 to the front, and decrease the power by 1. Same with the next one. This is x to the first. So we're going to bring the 1 to the front. 4 times 1, still 4. And decrease the power by 1. And then the derivative of 5, the derivative of a number, the derivative of a constant is constant. It's 0. It doesn't change. So that constant just goes away. That's the derivative. 3x squared minus 4x. And so for b, well, hold on. We need to write this better. This is not equal to. This is y prime equals that. Or f prime equals that. So let's do that here. So g prime, the derivative of this is, let's see. So we bring the 4 to the front, but then the 4 is going to cancel with the 2. So let's write that out actually. So we still have that over 2, but then it's x, decrease the power by 1. So 4 minus 1 is 3. So 4 times x cubed over 2. We'll simplify it later. So then bring the 3 to the front. 3 times 3 is 9. So 9x squared. And then the derivative of negative 2x, you end up getting this pretty quickly once you have it. Once you've done it enough times, the x just goes away. And so it's just negative 2. And there's our derivative. We just want to simplify it a little bit because you never want to leave unsimplified fractions in your answer. That's just gross. So 2x cubed plus 9x squared minus 2. And there we go. All right. Isn't it just 4? Since x to the 0. Frick. Yeah, it is. Yeah. Why did I do that? You're right. That's annoying. Yeah. What did I say? Didn't I talk about that? Or did I just not even talk about that? That's annoying. See, I don't want to edit the video. This makes me want to redo it all. I know I did a couple last night where I was going to edit them. I guess I have to now, but I really don't want to. A. Franco, thank you for pointing that out. So let's do it again. All right, let's take the derivative of these. I made a mistake the first time. Let's not make that mistake this time. So what are we going to do? All this example is really trying to show is that if you got a whole bunch of functions added together, you just take the derivative of each of them separately, which we should have already known because we've already learned that. But here we're just showing that it works for power rule as well. So power rule, x cubed. Bring the power to the front. So bring the 3 to the front and decrease the power by 1. Make it x squared. Negative 4x, that's x to the first. So you move the 1 to the front. 1 times 4 is still negative 4. And then x to the first, when you decrease it by 1, now it's x to the 0. So we'll go ahead and write that out. 1 minus 1. But then, yeah, let's make it better now. So what is 1 minus 1? Well, it's 0. So we end up with x to the 0. So 4x to the 0, 3x squared. But then, yeah, x to the 0, which you see in the comments was my problem, is 1. So this should just be 3x squared minus 4 times 1, so just 4. And really, like, that's something that you should get just in the hang of very quickly, is that if it's just x to the 1 here, the x just goes away when you take the derivative. So see, like, we have the exact same scenario here with our negative 2x. So when we take the derivative, that's just going to turn into a negative 2. And then we do the derivative with everything else. Let's erase that because that looks like a fraction. So we take the derivative of negative 2x. We just get negative 2. We take the derivative of negative x to the 4th over 2. Well, the 4 moves to the front. Power decreases by 1. But the negative and the over 2 stay. And then the next power rule, bring the 3 to the front. 3 times 3 is 9. So 9x, decrease the power by 1, x squared. And then, lastly, you just got to cancel. So negative 4 over 2 is negative 2. X cubed plus 9x squared minus 2. And that is our derivative. Y3, did I make a mistake again? Y3 here? Because you decrease the power by 1. Or that's a 3 because you're doing this 4 minus 1. This is 9 because it's 3 times 3. So yeah, that's why it's 3. That's why Y3. I'm not sure exactly which part you're referring to, though. All right. Why is there an extra page there? Oh, it's not. That's just small. So we're not even doing scarier power rule stuff. Did we do that later? I feel like we're missing a lot of examples that we should have about power rule. And look how B, they're like doing half of B for us. Yeah, I did all those. Did all those. Then you get to that. Is there not like a harder power rule section? Like, yeah, I wanted problems like that. I mean, there's only 2 of them here, but I think that's critical. Maybe not. I mean, I do just want to do the examples. If I go and add in my own stuff every single time, that's I'm gonna take forever. I'm just gonna keep adding and adding. So I guess we should really just leave that as a exercise to the reader to find out when you do stuff like this. Wow, look at how much work I did here. This is the year that I taught calc. Okay. So let's go back to this. So now we're getting into the derivative of sine and cosine, but I do just want to take a quick second to point out that there's more complicated stuff you could do for the power rule. So like, for example, that's actually just a power rule problem. Something like this, that's actually just a power rule problem. So just be careful and realize that power rule works for other things too. So let's go ahead and do these problems. So first off, there's just a little knowledge we have to know. We have to know what the derivative of sine is and what the derivative of cosine is. So let's start with the derivative of sine. So if y equals the sine of x, then the derivative, y prime, is the cosine of x. But then if we have cosine, the derivative of cosine, I'll rewrite that over here. If y equals cosine of x, the derivative is negative sine of x. So those are two things you just have to know. I suppose we could probably find them with the limit definition. Maybe we'll do that as well. But we just really need to know these. And one thing that is interesting is look how it's going to cycle. So like if we did the second derivative, we took the derivative again of cosine. Well, we just said it's negative sine of x. But then if we take the derivative again, well, the derivative of sine is cosine. So the derivative of negative sine is negative cosine. But then if we take the derivative again, the derivative of cosine is negative sine. So the derivative of negative cosine is negative sine, which is positive sine. I'll write that negative sine, which is positive sine. So see how it cycles every 4. Kind of like I to the first, I to the second, I to the third, I to the fourth, and then it cycles. So pretty neat. And then we really just need to memorize that. So like here, the derivative of sine is cosine. So the derivative of 2 sine, y prime, is 2 cosine. And then B, I'm kind of annoyed they rewrote it for us because we should know that sine of x over 2 is 1/2 times sine of x. So we do that anyway. Y prime is 1/2 cosine of x. And like I said with the last problem, it's nicer to write it how it started. So let's rewrite that as cosine of x over 2. Okay, beautiful. Now C, again, kind of like we talked about with the last problem, if we got functions added together, we just take the derivative of each one. So the derivative of x is 1. Why? Because this is just 1 times x to the 1. So when we bring the 1 to the front, 1 times 1 is still 1. X to the 0 is also 1. So the derivative of x is just 1. And the derivative of cosine is negative sine. So the derivative of this, y prime, is 1 minus sine of x. And so you really do just have to know those. You have to know that, and you have to know that. So should we try to do that with the limit definition? That's going to be tough, but we can probably try. So let's try to find if y equals sine of x. Let's try to do the limit definition. So we're going to do the limit as h approaches 0 of sine of x plus h minus sine of x over h. And I know this can get pretty challenging, but let's try it out. So one thing you should know from pre-calc is the sum of angle formulas. So if we have sine of x plus h, we can rewrite that. I have a song, so it goes sine, sine, cosine, cosine, sine. So we'll do sine, sine, cosine, cosine, sine. So I guess I did just talk about how you shouldn't memorize things like that. But some things I think you just have to. So I have a song for that. Sine, sine, cosine, cosine, sine, cosine, 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 sine, sine. And that does both of them. That does the sum of cosine formula as well. So anyway, now we have this. So the point of this is... What is the point of this? That's a good question. Well, I'm looking at this. Now keep in mind, I don't really know what to do here. But I see that there's a sine of x in both of these. So I'm going to write this so that it's proper first. And then I'm going to go... And I'm going to try to rewrite this and factor out the sine of x. So we'll have sine of x on this first part, and then cosine of h minus 1, because that's minus sine of x, but we factored it out. And let's see, I really just want to separate these. So we'll have that fraction, and then we'll have this fraction. And then what can we do from here? That probably was brilliant. But we're not done yet. We still got to finish it up because we still can't plug in h equals 0. Except this part we can do right here, actually. This part, because... okay. I see. So another thing, we went over this that you just have to know, is that the limit as h, well, normally it's x. As x approaches 0... of sine of x over x is 1. You should know that. So this part right here, realize if we have the limits of things added together, you just take the limit of each of them. So we should know that from the last chapter. So my Apple Pencil just died. Can you believe that? We're not even going to edit this out. We're just going to sit in here for a second. Plus, you'll get to appreciate how quickly the Apple Pencil charges. Because see, we just plugged it in. And now we're going to unplug it. Oh, we'll wait a little bit more. Because what, we got 15 more minutes it needs to last? That will absolutely last the 15 more minutes. Alright, so now we plug in the iPad again. And it'll take a second to turn on, but it'll be there. And while we wait, I'll go ahead and rewrite what we had just said. That we're going to take the limit as each of these separately. So we're going to take the limit of that one separately. And we're going to rewrite it to see that we have this. So when we take that limit as h approaches 0, like the real issue here is that part. But we just said that that part equals 1. So when we take that limit, that's just going to become 1. That's going to be cosine of x times 1. That's just going to be cosine of x. And then we're actually going to do a very similar thing over here, because that's another limit that we need to know. That if we have, so we have the sine of x times cosine of h minus 1 over h. And similarly to this limit, we have to know that the limit as x approaches 0 of cosine of x minus 1 over x is equal to 0. So look at what's happening there. We're ending up with sine of x times 0, which is why that just goes away, and the derivative is just cosine of x. That's beautiful. I'm not sure I've ever done that before all the way out by myself, to be honest. Should we do cosine too? I feel like we're here. We might as well do cosine. We're going to need another page for that, though. Because it'll basically be the exact same thing. We'll use the sum of angle formulas. So... oh, wow. And is this just going to be negative because it's negative in the sum of angle formulas? That's going to be interesting. So what do we have? The cosine of x plus h minus the cosine of x over h. So just like before, we're going to use the sum of angle formulas. So the limit as h approaches 0 of the cosine one. So it goes sine, sine, cosine, cosine, sine, cosine, 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 minus... that's the trick there. Sine, sine. Beautiful. Minus cosine of x. All of that over h. And then we're just going to do the exact same thing we did last time. So we're going to rearrange them, but then we're going to factor out the cosine this time. So again, it's the first and the last term. So we have the cosine of x that we factor out. So we're going to be left with the cosine of h minus 1. Because remember, just like before, that's right here. But we're factoring out the cosine of x. Beautiful. And see, that's like exactly what we got there, except there was sine of x times that. Very interesting. And then what do we have over here? Minus sine of x, sine of h. And yes, see how that was plus last time because this was a plus. But now in the sum of cosine formula, that's a minus. And so that's why that's going to be a minus. And again, just like before, we're going to separate that into the two separate fractions, over h and over h. So again, just like before, sine of h over h, that's 1. So this last part just remains negative sine of x. And cosine of h minus h over h, of course, when h approaches 0, that's just 0. So all we're left with is the negative sine of x. So that's really beautiful because it's one thing to have somebody tell you or plug it into your calculator to find just what the derivative of sine of x is, but it's a whole nother thing to start from your like fundamental definition of what's a derivative and really work it out. And it's really nice to at least do that for yourself once. Obviously, you don't do that for yourself every time, but doing it for the first time to see what it is, that's awesome. All right, good stuff. That was a longer one. Notice the Apple Pencil made it through the rest of the time. And I bet it'll last another 9 minutes. Okay. So what's next? Yo, Hop West, welcome. Thank you for those likes. Okay. So now we're on to this one. Let's read it first. If a billiard ball is dropped from a height of 100 feet, its height s at time t is given by the position that. Obviously. So we should even know that because that's just your basic physics equation. So where s is measured in feet and t is measured in seconds, find the average velocity over each of the following time intervals. Average velocity? Why are we talking about average velocity? Oh, because we're seeing how it goes. They don't ask for the instantaneous velocity? Did I miss that in the textbook? Surely. What section is this? We already did that. This is supposed to be section 2? No, they don't ask for that. We're going to do it though anyway. Wait, we're here. Okay. Let's do it. So here we got a word problem because, of course, application of math is important to some people. So if a billiard ball is dropped from a height of 100 feet, its height s at time t is given by that function. And, of course, you honestly should be able to write that function on your own because that's the classic physics equation. You got your acceleration times t squared. I guess that's not a naught because the acceleration is constant. So a, your acceleration times t squared plus your initial velocity times t plus your initial position. And so see how we got our acceleration due to gravity because the acceleration due to gravity is like negative 32 feet per second-ish. And you got your initial velocity is 0 because it's just dropped and from a height of 100 feet. So that's why this is plus 100. Except for I just realized I said that the acceleration was negative 32, and so it makes sense that it's negative 16. That's because it's a over 2. Right. So this makes much more sense. That's our physics equation. And so when we do this, we're actually not even going to be taking the derivative, right? Because they're asking us to find average velocity. So average velocity, that's the secant line. That's the slope between 2 points. So first off, we got to find these points. So let's say when x equals 1, so I'll write s of 1. Because see how it's like they didn't write s of x or s of t, but it's the s function, so I still think that's legit. So we'll say s of 1 is what do you get when you plug in 1? What is the height after 1 second? Well, 1 squared is 1, so negative 16 plus 100. So 100 minus 16 is 84. So it's 84 feet at 1 second. And then, so recognize again, that's our point. That's the point 1 comma 84. But then what about at 2? What is s of 2? How high is it at 2? Well, negative 16 times 2 squared, so 4. So negative 16 times 4 plus 100. So what's negative 16 times 4? That's 64. So negative 64 plus 100. So 100 minus 64 is 36. So that's the other point, 2 comma 36. So what is the average velocity? Well, let's just find the slope between these 2 points. So let's do 84 minus 36 over 1 minus 2. So what's 84 minus 36? That's 48. So 48 over negative 1. So the velocity is negative 48 feet per second. Let's check that. 84 minus 36. Yeah, that's definitely 48. So negative 48 feet per second. Okay. So that's part A, from 1 to 2. Now we're looking from 1 to 1.5. So what is S of 1.5? So they might want us to use a calculator here, but I'm not down for that. So that's why fractions are nicer. So we're going to change. So 1.5 is 3 over 2. We should know this. So 16 times 3 over 2 squared plus 100. And see how that's way better, because how do you square a fraction? It's 3 squared over 2 squared, which means that this 2 squared can cancel with the 16 to make it negative 4 times 9 plus 100. That seems a little familiar, but it's actually the opposite, because now that's negative 36 plus 100, so we get 64. So at 1.5 seconds, let's do that, we get 64. And so what is the slope between those 2 points? You go the first point we had, so 84 minus 64 over 1 minus 1.5. So we end up with 20 over 0.5. And so 20 divided by 0.5, this actually reminds me of a math problem I saw people doing yesterday, where they were doing long division to do, I think it was like 4 divided by 0.5. And I was like, oh, that's so painful. First off, I don't believe in long division as a concept anyway. Second off, if you're dividing by 0.5, dividing by a half is multiplying by 2. So we don't need to do anything. We just need to do 20 times 2 and get 40. And there we go. There's our average velocity from 1 to 1.5. So next, let's do it from 1 to 1.1. So first off, we have to find S of 1.1. So let's see. That might be nicer to use a calculator, but I'm persistent, so I'm not going to. Plus, I can do 1.1 squared pretty easily, because that's just 11 squared. And 11 squared is 121. So this is 16 times 1.21, which again is going to be better with a calculator, but I don't like calculators. And then plus 100. So what is 16 times 1.21? Well, 16 times 1 is 16. And then 16 times 0.2 is 16 divided by 5, which is 3.2. And then 16 times 0.01 is 0.16. And then plus 100. Did we drop the negatives? We dropped the negatives. All of that was negative. Negative, negative, negative. So what is that then? Negative 16 minus 3.2 is negative 19.2 minus 0.16. So we end up with negative 19.36. You know what? I feel like we should make sure that that's correct. So let's pull up NumWorks right quick. And because, we all make mistakes. So 1.1 times 1.1 times 16 is 19.36. Boom, 19.36. You'll love to see it. So negative 19.36 plus 100. We don't need a calculator to check that one. That is 80.64. Beautiful. But we're not done yet, because now we have to find the slope. That's just the point. So now we got to find the slope. It's going to be 80.64. Let's see. Let's be consistent. So let's do 84 minus 80.64 over 1 minus 1.1, which I actually realized, let's step back real quick here, that's a negative 0.5, so that's a negative 40, which makes a lot more sense considering this was negative 48. This is going to be negative 40 feet per second. And then let's continue here. We have negative 0.1 on the bottom. On the top, 84 minus 80.64, so that's 3.36. Because if you have to write anything down, you should use a calculator. But you should be able to do 84 minus 80.64 in your head. You could even check it real quick to make sure it makes sense. 80 plus 0.64 plus 3.36. It does indeed get you 84. So you're happy on that. Right? Because it fills up, so it gets 81 plus 3. Yeah, so that's 84. So then 3.36 divided by negative 0.1, that's, well, remember, you're going to multiply by 10. You're going to move this decimal over. So you're going to get negative 33.6 feet per second. And so those are all the average velocities. Negative 48, negative 40, negative 33.6. And at first I was worried that was a big jump, but it's the same jump as the other one, so that makes sense. But what I wanted to do next is kind of see what it's getting at here, because you're doing from 1 to 2, and then you're doing from 1 to 1.5, and then you're doing from 1 to 1.1. So see how these keep getting smaller? It's kind of like they're getting closer and closer to some answer, to some specific number, to some specific velocity. So let's find the instantaneous velocity. Like we do calculus now. We don't need to find these average velocities. We can find the specific velocity at time equals 1. So let's go ahead and do that. Let's find the derivative. So s prime of t, since this is all in terms of t, is what? That's just the power rule. So, and also s prime. What is s prime? The derivative of the position is the velocity. I guess we should have said that from the beginning too. That you take, the derivative of the position is the velocity, because it's the rate and change of the position. The derivative of the velocity is the acceleration, because it's the rate of change of the velocity. How the velocity changes, which is what acceleration is. But we don't care about that here. We just care about the velocity. So what is the derivative? Well, power rule. So bring the 2 to the front. 16 times 2, negative 32. You see, that's our acceleration in the first place. Times t, because you decrease the power by 1. And then the plus 100, that just goes away, because the derivative of a constant is 0. And then now we can just plug in t equals 1. So we say, what is the velocity? The pencil almost made it. Made it 2 minutes after 9, but not to the end of the video. So watch this. The pencil was dead. We're going to plug it in like that. And then we're going to finish the video, because that is all it'll take. Because we're almost done anyway. We found it was negative 48 from 1 to 2. It was negative 40 from 1 to 1.5. It was negative 33.6 from 1 to 1.1. And exactly at 1, v of 1 is negative 32 times 1. So negative 32. And you see how that works out. That it goes from 48. We look a little more specifically, 40. A little more specifically, 33.6. And then we go right on, and it's 32. So you see how it gets closer and closer to 32 as that time interval gets closer and closer to instantaneous. So that's a pretty cool example. We probably made that take way longer than it needed to, but that's part of the fun of it. Wow, I just missed the hit recording button, or the stop recording button. I just got really scared for a second that I was never recording, because I clicked it, but then it said stop recording. Ugh. But then I was like, wait, no, I just looked down and it said it was recording for 11 minutes. So That should be fine. Wow, could you imagine if the microphone wasn't on now? That would be bad, but it is. All right, how many problems did we do? Really, the goal is only 2, to be honest. Maybe 4 if we want to double up. How many we did? We did more than 4. 1, 2, 3, 4, 5, 6, 7. We did 7. Beautiful stuff. We did 7. Oh, so that's 3 days worth, 3.5 days worth. All right, good. So I really am going to start posting these to YouTube, especially if I got this MathLab time to come in here and make these. If no one's going to come for actual math help. But I wish people would come for actual math help. But it's still not publicized very well. Or even really steady on this is the way to do it. I think this is the way to do it. I don't think we need to do it on Zoom. I mean, it could be on YouTube. Like, if you're watching on TikTok right now, YouTube is a better way to watch. Because there's a lot less delay. There's like a good 10-second delay on the TikTok. So you're definitely better to watch on YouTube. You'll get more immediate help. So if you want to go to YouTube, that's... my pencil's dead. MathLab.online/YouTube. I'll put it up real quick. Whoa. I just want to draw text. I just want to type. MathLab.online/YouTube. And actually, what you could probably do, you could also just go to my main website. Well, here, if you're going to do that, that's got to be //YouTube. And then actually, is that just a link right there? Did that just link it? We could just, create web clip. There you go. There's my subscriber. There's my deal. You can see I'm live right now. That's pretty cool. Well, here, let me just check this then. So what if I typed mathlabjordan.com/YouTube? That also works, right? I didn't do the slash. That works too, right? Can I make another web clip of that? No, that does not work. Whoa, and it starts talking in French. Is that not the website that I have? It goes to YouTube snip feed. That's trash. Hang on. I forgot that it did that. Hold on, that's what I really wanted. What are all the links we got here? All done by Hover, by the way. Not sponsored, but incredible. Should be sponsored. I wonder if I can just get an affiliate link. Probably not. I mean, Hover's the way to go. If you watch any podcast, you've heard about Hover. See, this is what we got. Yeah, mathlabjordan.com. I do have that website. Do I not have that forward done? No, I don't. Well, let's create a forward then. mathlabjordan.com/YouTube. Forwarding to... What's this? Shoot. Boom. Now that'll work. In like a second. You gotta let it go. You gotta chill for a second. But it'll work. Yeah. See, these are all the good links. That's my Zoom. Don't actually have the like actual MathLab here. Snip feed. I need to work on that more. Game show. If you want to be in a game show, I'm putting on a game show. We got that coming up soon. Thinking next Thursday. It's looking like next Thursday. It's very exciting. Need to make a video about that soon once it's all set. But that's very exciting. So yeah, anyway, you can watch better on YouTube, but that's up to you. So say, am I not streaming? No, I'm still streaming. As you see, people don't really watch on YouTube either. It's probably me. But anyway, that was fun, y'all. That's it for MathLab. We'll be back tomorrow. Same time, same place. Peace out, everybody.